It's Monday. All over the world, a population of 200 million people is waking up, walking into their offices, and starting an application they're likely to use at work daily. The program is 41 years old.
Now hold still, I'm about to perform a miracle.
It is full of features, old and new, and despite the competition providing free alternatives, this application isn't being replaced anytime soon. Of course, I'm talking about Microsoft Excel.
All you do is point and click.
Excel has come a long way since the 1980s. Frighteningly, only 1 in 3 users ever become comfortable with logical formulas. Today, let's fix that. We are stepping into the world of advanced Excel, beginning with lookup formulas. Let's start simple. In front of us, we have 3 columns: fruit, price, and availability in our grocery store inventory. Cell F3 has a border around it, and I want to make sure that the fruit I type into the bordered cell exists in the fruit column of the sheet. For example, when I type apple, I want the green cell to say yes. This is a perfect fit for the match formula, which is the first lookup formula I recommend learning. In our green cell, type an equals sign, this initiates the formula, and then type match. Open parentheses and click on the bordered cell to establish our lookup value. Type a comma, click and drag your mouse cursor on the entire list of fruits from our grocery store data. This is the lookup array. And we'll specify an optional criterion, which is match type. We're going to set this to 0, exact match, and then close the parentheses. As you can see, the number 1 is the output of our match formula. Apple is the first item in the lookup array that we specified. Type in any fruit name in our list, in fact, and you'll get a positive row number, and this will become useful in a second. Type in a fruit that doesn't exist, and you'll see an error statement returned. Now, I did promise the result would be yes, and for this to happen, we can simply wrap our existing formula with an if statement. Now, remember, any accepted match will be a number starting with the number 1 or higher, so let's use this simple logic to our advantage. Double-click the green cell, or you can click on the formula above if you like, and click to the right of the equals sign. We'll put the cursor right here. Type if, followed by an open parentheses, and now click to the rightmost area of your formula and type greater than 0. Put in a comma, and then in quotations type yes. Now close your parentheses, and as you can see, we have an if statement that wraps our match formula. What this means is anytime our chosen fruit matches the list in column B, the output will be yes. Any incorrect matches will still result in an error. This is good enough for our use case, as we're able to pinpoint exactly which fruits are in the list and which fruits don't qualify, simply by typing in the cell. Sometimes, error messages on their own can be just as helpful when using Excel formulas. In fact, sometimes the error flag can be the intended use of a formula. So let's apply this concept to another example of match. January staff details are being compared to February in my spreadsheet. Our goal is to find the February employees that do not show up in the January staff list. These are the new hires for the month. Before we type, let's turn both of these lists into tables so that we can make our data and formulas a lot cleaner. To make this happen, let's click and highlight our set of January data, headers included, navigate to Insert, Table, and double check that this is the range that we want to convert. Since we are including headers, go ahead and make sure that checkbox is applied. Click OK, and you'll notice our table is much more readable than before. Now I'll go ahead and fix the header colors too, and I'm also going to name this table January. Repeat this process for the February staff, and we are ready to type our match formula. Let's name this list New Employees. In the cell below, type equals match, open parentheses, and our lookup value is going to be the February email address. Let's select our lookup array, which is all January emails. We're going to set this to 0. Since we made the January and February lists into tables, Excel told us which table columns we selected for the list instead of just giving us a row column range. Not only is this method cleaner, but it greatly improves formula readability, especially since we named our tables. Now, let's click on the handle at the bottom right of the cell, and we'll drag this formula down alongside each February row. So now that we've dragged the formula down, can you spot the new hire? If you said Thomas Morris is the new employee on this list, then you're correct. Now, if you were to tell me that Morris is a name that you can spot from a mile away with its awkward two-syllable cadence and overemphasis on its first vowel, I wouldn't blame you. However, if this name appeared in a list of hundreds or even thousands of rows, then I think you'd be thanking me for not letting this oddball name escape your sight. This was an example of using the match formula to report an exception between two lists. Let's go back to the grocery store. This time, we want to find the prices of fruits given in column G. Also, our grocery store list has already been converted to a table named fruits, so just like in the last example, this is going to keep our formula cleaner. To find the price of a fruit given its name, we can use X lookup. Let's find the prices of the banana and mango on our list, and then I'll show you why, in my opinion, this is my favorite lookup formula to use when faced with increasing complexity. To begin, select cell H4, type equals XLO, and Excel already knows that we want this formula. Press the Tab key on your keyboard to automatically complete XLOOKUP, and we are also given an open parentheses, which is very handy. Typing the rest of the formula, the first criterion is lookup value, which is banana, and our lookup array is going to be the list of fruit names. So far, this is identical to how we used the match formula from earlier, but type another comma, and we are stepping into new territory, which is selecting the return array. We want the output in our green cell to be price, so the return array will be the list of possible prices in our grocery store. Do you see where this is going? I'm also going to add in one optional criterion, which is match mode. So let's type 2 commas, comma, comma, and type in a 0 for exact match, and close parentheses. Now press enter, and the resulting price is now available at the press of a key. If we drag this formula down to the next row, we see the price of the mango. And if I change the word mango in this cell to apple, the price automatically adjusts for that fruit as well. Now I have a question for you. Apple returns $1.40. However, if we take a look at the list, apple shows up more than once. So to our alarm, the 3 apples in our grocery store have 3 different prices. But why is this the case? Why was $1.40 selected? Well, XLOOKUP, as written currently, only returns the first matching result from our list per fruit. In this case, the first apple that XLOOKUP captured was the $1.40 Red Delicious type. But what if we wanted to know what the price of the Fuji apple without changing the list? Grocery store data is starting to get interesting, and we are ready for XLOOKUP with multiple criteria. Right-click on column H and select Insert. Name the header Type, and we are going to list the apple, orange, and grapes of choice that we would like to find for pricey information. I want a Fuji apple, a blood orange, and let's say green seedless grapes. Let's begin writing our XLOOKUP formula. With multiple criteria, the rules are a little different than before, starting with our lookup value. Write the formula as usual, open parentheses, but now simply type the number 1. This number represents a concept for Boolean logic that Excel is conducting in the background, and this can easily be the subject of another video. But for now, our lookup array is going to consist of 2 columns, so stay with me here. Type in one set of parentheses, open and closed, followed by an asterisk, and then type another set of parentheses. We will come back to this in a second. Type a comma, and our return array is going to be the same as before, which is price. Like before, I also recommend typing 2 commas and 0 to secure the exact match. Okay, are you ready to finish this formula? Click on the area here, right between the first set of parentheses and our lookup array. Select the fruit name column from the grocery list, and then type equals and click on the fruit name of choice. Place your cursor in between the second set of parentheses, select type from the grocery list, equals, and click on the fruit type of choice just like with fruit name. Before we press enter, take a moment to understand what is happening in this formula. We just told Excel to search for a match between apple fruit name and Fuji fruit type. Then, to list the price in the cell where we typed the formula. Let's drag the new lookup formula down to find the prices for the blood orange and green seedless grapes. For each fruit specified, the prices match those listed for our grocery store. The fact that we can scale XLOOKUP to handle 1, 2, or even more criteria simultaneously is why this formula is my favorite to use during day-to-day work, even if it gets a little more complex than I expect. It's easy to use, yet flexible enough to modify, and still have a reasonable result. In my opinion, the best Excel formulas are also the most flexible. The rest of the cells in the output range should be populated by dragging the original formula where needed. For example, for each fruit listed in column H, strawberry, pineapple, and watermelon, we need to find the price per pound of each fruit. This is not totally unusual, but we also want to find if the fruit is in stock, and let's factor this new sales rank category into the mix. Let's try using our XLOOKUP function the way that we wrote it previously. XLOOKUP, strawberry, from our list of fruits, return price, specify exact match, close parentheses, and press enter. I mean, come on, that was too easy. Drag the formula down our price column to return the prices of each fruit, and we are given the information that we need. Drag the strawberry rose formula to the right, and incorrect. This formula's limitation is revealed. It only works effortlessly in one dimension, which is down each row, but across each column, we're going to need something more powerful. Let's find out how to retrieve the information we need using the current formula, but then let's use a lookup function so powerful that it will solve our problem the easy way. In order to use the current XLOOKUP formula to solve our dilemma, try reordering the output columns until they're identical to our fruits table: in stock, sales rank, and price. We can retype the lookup formula in cell I4. XLOOKUP, cell H4, the fruit name column, return in stock column, specify 0, and close parentheses. Let's also introduce anchors. An anchor tells Excel how to lock a specific row or column when a formula is dragged across a range of cells. For example, if I drag this formula one column to the right, we can examine why it's incorrect. We can see that cell I4 is selected as our lookup criteria. We want cell H4, fruit name, to be selected, so we need to lock column H before we drag our formula to the right. Go back to cell I4, edit the formula, and type a $sign in front of letter H. The same approach works whether you're locking rows, columns, or even both at the same time. To alternate between each set of anchors, or the $signs in this case, press F4 on your keyboard. As we repeatedly press F4, Excel alternates between locking the row and column, row only, and then column only. Our return array requires anchoring as well. Instead of $signs, our syntax is going to be a little different since we're using a table object for our formulas. Click on the table's column name, type a colon, and then type the column name a second time. Make sure it's wrapped in square brackets. Wrap the statement in an extra set of square brackets, and we're done. If I drag this new formula to the right, we can see what is happening. XLOOKUP searches our anchored fruit name and lookup array, but for each column where the formula was dragged, the return array becomes in stock, sales rank, and then price respectively. Now, this manipulation took too much effort because in reality, we should really consider reordering columns to suit our data needs. What we've done so far is helpful in a pinch, but let's put XLOOKUP aside for a moment. I want to be able to place output columns I, J, and K in any order that I please. How do I make Excel recognize column names instead of their relative positions? Introducing the easy way. Let's take a look at the index formula. With index, we are playing a game of coordinates. For example, the answer to if a strawberry is in stock is revealed in row 12 of our fruits lookup table and column 1, 2, 3, 4. I'm going to type equals index, open a parentheses, and only select the body information of this table, ignoring headers for now. Next, just like we planned, type 12 for row, add a comma, and type 4 to reference the table's fourth column. Close parentheses, press enter, and the result of the index formula shows the stocking status for the strawberry. In reality, it is silly to manually type numbers into index, but if you recall from earlier, there is a formula that can retrieve row numbers and column numbers automatically, and we have already used it. We are bringing match to our attention once again, but this time, we are going to nest it inside of our index formula. Better yet, we are actually going to do this twice. One match formula to find our row of choice, and another to retrieve our column number. Understanding nested formulas is easier when we first write them out separately, then combine them into one cell at the end. Let's refresh ourselves on using match to retrieve a row number. In cell M7, type equals match, open parentheses, specify the fruit that you want to find, I'll type peach in quotation marks, and select our lookup array, which is fruit name. Make sure to specify 0 for exact match, and close parentheses, and press enter. We have done this part before, but this formula tells us that the peach exists in row 11 of our fruits column, ignoring headers, of course, for now. Double-clicking cell M7 and replacing peach with banana changes the output. It reveals that banana is in row 4 of fruits. We can set this formula aside, and now we will turn our attention to finding the column number for sales rank. In a different cell, type equals match and type sales rank in quotes as our lookup value. This time, the lookup array is the entire header row of our fruits table. Notice how when all headers are selected in an Excel table, the syntax becomes the name of the table and hashtag headers is enclosed in square brackets. If you call this a pound sign, then that's wonderful. Type that last comma, specify 0 for exact match, close parentheses, and press enter. This time, match is used to reveal that sales rank is in the 5th column of the header row. Finally, we have all of the ingredients necessary to create a simple yet effective Excel lookup formula where typing it correctly once enables us to drag it across a range of rows and columns. I'm going to clear columns L and M, unhide the space we worked in earlier, and type a dynamic lookup formula referred to as index match match. To start, type equals index, open parentheses, and select the information of the fruits table by clicking and dragging with your mouse, or simply type the name of your table in the formula here. We can see that the range is highlighted, indicating our data is selected. Yippee! Type a comma, and we arrive at the row requirement from earlier. Remember, this row number slot for index is going to be an entire match formula. It's just going to be inside of index. All we need to do is type match, open parentheses again, specify strawberry, our lookup value, and the lookup array, which is, of course, fruit name. And as always, type in 0 for exact match, close parentheses, but do not press enter yet. Take a moment to observe a nested formula inside of index. Red inner parentheses help separate the match formula from the black outer parentheses used to wrap index. Type another comma. This time, let's specify the column number using the same match approach. Just like before, type match, specify the column lookup value, which is type in the cell above, and specify the lookup array, which is our header row of the fruits table. Either drag your cursor across the header column or simply type fruits, hashtag headers in square brackets. A highlighted range will again appear on the table. Type comma, match type 0, close parentheses once, and then close parentheses again. Before we press enter, let's anchor the criteria that we already typed so the formula can be dragged correctly. We want to anchor the row lookup value, so if we drag the formula to the right, we can still be searching for strawberry in column H. Click on H4 here, type a $sign to anchor the column, and let's move on to anchoring the fruit name column with a colon and double brackets. Remember that a table name looks slightly different than a cell reference. And that's better. Finally, let's anchor our column reference I3. If we drag the formula down, we still want to be searching for headers in row 3. Therefore, type a $sign before the 3 to anchor this criterion. That is all for anchors, since we do not need to modify our hashtag headers in any way. If anchoring is new or a bit confusing, then there is no need to worry for now. It is easier to show the effect of anchoring when we are finished typing the formula. Speaking of, to finalize what we have been working on, press enter. Drag the formula to the right across our column range and down each row where needed. Index match match has found all available row and criteria columns dynamically with just one formula. Let's take a look at why this works. Select cell K6 and click the formula bar above. We can see how the formula indexed our entire table, and match worked to identify watermelon from the fruit name column and price per pound from the header row. Press the escape key and let's visit another cell. Try J5 this time. Clicking on the formula bar, notice cells J5 and H3 are compared against the fruits table this time. Okay, one more. Press escape, click on cell I4 and head to the formula bar again. Cells H4 and I3 are the adjacent criteria looked up against our fruits table. Do you see the pattern by now? Revealing any formula in this 3x3 grid shows index match match is playing the same game of coordinates that we attempted manually. This entire formula is designed to work for us. Anything changes, and the row and column of our criteria update automatically. As a bonus, try changing your criteria names on the fly. I'm going to swap strawberry with peach and sales rank with in stock without modifying any of the formulas in any way. See what happened? Type in any available fruit and header name from the fruits table, and Excel will retrieve the new results instantly. What we just learned with index match match is applicable using XLOOKUP, by the way. All you need to do is nest XLOOKUP by using the same formula twice. Follow me. Start an XLOOKUP formula, focusing on the row lookups only. After specifying fruit and fruit lookup array, as we've come to expect, the return array becomes another XLOOKUP. This one's nested. Type the formula, open parentheses, but this time focus on the column lookup only. That is, find the correct column from your header criteria, like before with that second match formula. We want type. Lookup array is fruits, hashtag headers in square brackets. And the return array is the entire fruits table. This was that first step from index. It's sort of flipped around here. Use 2 closing parentheses to complete the formula, then go back and anchor the cells that need to be anchored. I will move quickly this time, but feel free to pause or rewind to see anchoring in action if needed. Finally, press enter. Drag the formula across each green row and column, and voila! We have a nested XLOOKUP that works in 2 dimensions, just like index match match. The syntax looks different, but the same result is achieved. Congratulations, we are now deep in the rabbit hole of lookup formulas, but trust me, this is only the beginning.